What's happening, people? So here we are for video number 2 on limits in AP Calculus AB. We are going to focus in on the limit existence theorem today. It is probably the most important part of these early sections of this unit. So you're going to want to make sure that you have this down. You will need to know the limit existence theorem. You will need to be able to cite it, use it, demonstrate it in almost every open-ended problem that you do regarding limits. So, at this point we've talked about limits from the left, we've talked about limits from the right, we've talked about limits at infinity. We've talked about different types of graphs, we've talked about holes, we've talked about asymptotes. All these things are building to this limit existence theorem. So hopefully this will make sense. The theorem itself says the following. It says, the limit as x approaches a of f of x exists if and only if the limit as x approaches a from the right of f of x equals the limit as x approaches a from the left of f of x equals L. So the left-hand limit equals the right-hand limit, and they both equal L, where L is some real number. So what we're going to try to do now is use that information to answer some of these questions. So example 1, limits that do not exist. It says define each of the following from the graph. The limit as x approaches 2 from the left. The limit as x approaches 2 from the left. So we're approaching 2 from the left-hand side. So we have to visualize coming like this, following that line. So what's happening? The y values are getting larger and larger, so the limit does not exist, but we can actually say that it's approaching positive infinity. That will be your best answer in this case. However, in the end, you got to remember the limit does not exist because there is no such thing as infinity. Well, what about as x approaches 2 from the right? Well, as x approaches 2 from the right, we're going like that. Again, approaching positive infinity because what's happening is these values are getting larger and larger and larger. And then the next part says f of 2 equals what? Well, I'm looking at 2 and I'm seeing a vertical asymptote. So I'm going to go ahead and say that f of 2 does not exist or is undefined. Question in the end, does the limit as x approaches 2 of f of x exist? Why or why not? The answer is no. The reason is because if you go back to the limit existence theorem, which we had up top here, it says the limit only exists if both sides approach the same thing. Well, you could argue they are, positive infinity, but they got to equal the same value, where L is some real number. Infinity is not a real number. So for the shorthand, what we'll write is no, because positive infinity is not real. Cool. I'm figuring out this video thing a little bit. Hopefully this is okay for y'all. Next one, find each of the following from the graph. Limit as x approaches 2 from the left. So again, take our handy dandy little mark here. We're approaching positive 2 from the left. Looks like we're getting all the way to this value, which looks like positive 2. Limit as x approaches 2 from the right, which is part B. Looks like we're coming like this, approaching from the right-hand side, because we're coming this way, right? And that's going to equal 2 also. F of 2, however, does not equal 2. F of 2 equals negative 3, so you got to be careful there. Because the hole means there's a little tiny dot that doesn't exist on that graph. So the question is, does the limit exist? Why or why not? As x approaches 2. So you got to go back to the theorem above. It exists if and only if the left-hand side limit equals the right-hand side limit. And I'm saying that backwards, so according to my writing, it's the right-hand side limit equals the left-hand side limit, and they equal the same exact value. Limit from the left, 2, limit from the right, 2, They both equal the same number, so the answer is yes. Yes, the limit as x approaches 2 of f of x equals 2 because limit as x approaches 2 from the right of f of x equals limit as x approaches 2 from the left of f of x, and they both equal 2. Complete answer. And I'm apologizing for my handwriting, but I'm doing the best I can. Last one on this page, and that will bring the end of my video for now. Find each of the following from the graph. Limit as x approaches 2 from the left. It looks like as we approach from the left, we are reaching a value of positive 3. And as we approach from the right, we are reaching a value of negative 3. So we're going to put a 3 here as we approach from the left. We're approaching 3. Remember, it's the y value. And we're going to put negative 3 here because as we approach from the right, we're approaching negative 3 for the y value. F of 2 is going to equal positive 3 because that's where the dot is. And again, the question is, does the limit exist or not? Why or why not? So pretty clearly, we have the limit from the left not equaling the limit from the right. So the answer is no, and that's our evidence. Limit as x approaches 2 from the left of f of x is not equal to the limit as x approaches 2 from the right of f of x. All right, well that's it for now, y'all. I appreciate you joining me. Hopefully you got a little information out of that. Take care.